Alright, so we are going to be looking at synthesis of ether phospholipids. Please take note, we have ester phospholipid and ether phospholipid. The ester phospholipids are the glycerophospholipids. So all those glycerophospholipids, phosphatidylcholine, phosphatidylethanoamine, they are ester phospholipids because that bond formed is an ester linkage. But we want to look at ether phospholipid. Please check the difference between an ester and an ether. If you have something like this is an ester linkage. But if you have something like this is an ether linkage. So this is ether functional group and this is ester functional group. So all the glycerophospholipids, they have this ester linkage. But ether phospholipids, this is what they have. So the ether phospholipid, we are going to be synthesizing plasmalogen and platelet activating factor. So those are the two ether fatty acids, ether phospholipids we are going to be synthesizing. Alright, so if you want to synthesize your ether phospholipids, always start with dihydroxyacetone phosphate. I'm going to be using structures of some of these so that you can visualize what you're synthesizing. Now, dihydroxyacetone phosphate, that's DHAP. Dihydroxyacetone phosphate is still 3 carbon, 1, 2, 3. Dihydroxyacetone. If you have something like this is dihydroxyacetone. If they say dihydroxyacetone phosphate, it means you have to attach a phosphate group here. So this is dihydroxyacetone phosphate. Now, the beginning of the synthesis of ether phospholipid, you always start with dihydroxyacetone phosphate. Dihydroxy, 2-hydroxy group, attach phosphate, acetone, and a ketone functional group. Now, the first step is you attach a fatty acid to the dihydroxyacetone phosphate. You attach fatty acid to carbon 1, and the fatty acid you are attaching is the activated form. So we use acyl-CoA, fatty acyl-CoA. And if fatty acyl-CoA is coming in, you know that what will be leaving is CoA. We are attaching only the acyl group at position 1. So we attach our acyl group on position 1, and we'll have our 1-acyl dihydroxyacetone phosphate. 1-acyl because we are attaching the fatty acid on position 1. So we now have 1-acyl dihydroxyacetone phosphate. The next thing is we are going to bring in an alcohol. We are going to bring in an alcohol to replace this carboxylic acid on carbon 1. So an alcohol, if you check very well, this is a long chain alcohol. This is a long chain alcohol. So the alcohol will come in and the fatty acid we added in the first step will be removed. So if I bring in an alcohol now, what I'll be having is not 1-acyl again. It's now 1-alkyl. So this place from here we'll be having an alcohol instead. So I will now be having something like this. So this is an alcohol attached. So it is no longer 1-acyl, but now 1-alkyl. You can see we've even gotten our ether functional group here. Because if you leave it as, if you want to form an ester functional group, ester functional group is formed between an alcohol. It's formed between an alcohol and carboxylic acid. But ether functional group is formed between an alcohol and an alcohol. So if you want to form ester, alcohol and carboxylic acid, if you want to form ether, alcohol and alcohol, remember this is an alcohol functional group that was here. The first time we attached carboxylic acid, we attached fatty acid. That was how we have an ester. But now we remove that and add an alcohol, because alcohol and alcohol will give us ether functional group here. So that was why we have this ether. So it is no longer 1-acyl, but now 1-alkyl. So take note that alcohol is coming in and displacing the fatty acid we added in the first step, in the first position. Alright, now the next thing is reduction. This 1-alkyl dihydroxyacetone phosphate will be reduced. And you agree with me that reduction means addition of what? Hydrogen. Are you seeing this double bond oxygen here? Will be reduced to an alcohol. So if we reduce this to an alcohol, we'll be having this. And if you check this very well, if I remove this first thing and this second thing, you agree with me that this is glycerol. This is glycerol. So now I now have one alkyl group on position 1 of glycerol and phosphate group. So how do we name it? 1 alkyl glycerol 3-phosphate. It's no longer dihydroxyacetone phosphate, but because we've reduced it, so it's now 1 alkyl glycerol 3-phosphate. The next thing is we want to attach another. Remember that fatty acid is always attached on position 1 and 2. We want to attach fatty acid here. So the fatty acid is attached. We bring in another fatty acid, and fatty acid is attached here on carbon 2. Remember, when you're attaching fatty acid, you call it alkyl. Acyl. When you're attaching alcohol, you call it alkyl. So now you bring in your fatty acid on position 2. So we're now having 1 alkyl 2 acyl glycerol 3-phosphate. So that's what we have here. 1 alkyl 2 acyl glycerol 3-phosphate. Please, this step is not long. Just understand what is happening. In your ether synthesis, just start with your dihydroxyacetone phosphate. From dihydroxyacetone phosphate, you attach fatty acid. But attaching that fatty acid, what you form is an ester. So you remove the fatty acid and add an alcohol, so you have an ether. So you have this. Then the next thing is you reduce the double bond on carbon 2 to an alcohol, so you have glycerol. After the reduction, you attach another fatty acid on carbon 2. If you notice here, we have this an ester functional group, but that's not a problem so long as we have an ether here on position 1. All right, so now we've gotten 1 alkyl 2 acyl glycerol phosphate, glycerol 3-phosphate. The next thing is phosphohydrolase will come and remove this phosphate group on carbon 3. So if it removes the phosphate group, what we are now having is 1 alkyl 2 acyl glycerol. This stuff now is now our precursor to the synthesis of either plasmalogen or platelet activating factor. So I'm going to clean this and I'll write only this one up here. Then we see how it can be used to synthesize plasmalogen and platelet activating factor. So please, this thing is not long. Okay, before I do that, let's use structure to visualize what we've done. Now I said if you want to synthesize ether phospholipid, always start from what? Dihydroxyacetone phosphate. So you draw your structure of dihydroxyacetone phosphate. Dihydroxyacetone phosphate is 3 carbon. Acetone, meaning we have a ketone functional group. Dihydroxy, meaning we have 2 hydroxy group. So if you look at this now, this structure here is dihydroxyacetone. I have to attach phosphate group here. So this is dihydroxyacetone phosphate, DHAP. Now the next thing, after you've done your dihydroxyacetone phosphate, the next thing is to attach your fatty acid. So fatty acid in the activated form, acyl-CoA, fatty acyl-CoA comes in and CoA is leaving out. So we are attaching only the acyl group. So the acyl group is being attached on carbon 1. So we'll be having this. So if I attach my acyl group, you agree with me that this is what I'll be having. So I've gotten my 1 acyl DHAP. But we are not interested in synthesizing an ester fatty acid. What we are interested in is synthesis of what? Ether fatty acid. So to synthesize our ether fatty acid, we have to remove this ester group and put an ether. So we have to remove this fatty acid and put an alcohol. So alcohol comes in and the acyl group leaves. So now if alcohol is coming in, we'll be having this. So at this point now, we now have an alcohol, CH2. Let me put another CH2 arrow. No, the OH is, please listen up again. This O, CH2, CH2 arrow. This arrow represents the alkyl chain, so it can be very long because what we're adding is long chain alcohol. Now we've gotten this. This is now no longer one acyl, but now one alkyl. One alkyl DHAP. Now, if you look at this, position 2, we're having a ketone functional group. So we have to reduce it. So reduction, NADPH comes in and reduces it. So we'll now have this. So this will be reduced to, please follow the steps. So if I'm reducing this now, I will now have an alcohol there. I will now have an alcohol. So what I now have here is now one alkyl glycerol 3-phosphate, because this is now glycerol, no longer dihydroxyacetone. The next thing is I can attach a fatty acid here now because I now have a free hydroxy group where I can attach fatty acid. So acyl CoA, another acyl CoA comes in and leaves as CoA. So the acyl group is attached there, and I'll be having CH2O. Please take your time on this. So here I'm on position 2. I'm now attaching my fatty acid. So notice that here I have an eta functional group. Here I have an ester. That's not our business. We've gotten eta functional group, which we wanted. So this is the eta functional group. Now if I want to name this is now one acyl, one alkyl, 2 acyl, because the acyl group is on carbon 2, glycerol 3-phosphate. Glycerol 3-phosphate. Now at this point here, the next thing that will happen is phosphohydrolysis. We remove this water. We remove phosphate group. So phosphohydrolysis, we remove this phosphate group. So we'll now be having CH2O. Then we'll have this. Now phosphate group has been removed. So we'll now be having OH here. So what we now have is one alkyl, 2 acyl glycerol. So I would even like you to draw it to the structures because it's interesting to draw structures. So what you do now, just calm down and take it bit by bit. Don't rush it. Pause the video and draw. Don't just be looking for. Start drawing. All right, so we are going to continue from one alkyl 2 acyl glycerol to see how we can synthesize plasmalogen and platelet activating factor. So draw this. All right, so I'll be drawing the structure of the last thing we had here, which was we had the structure of so this was the last structure we had there, which was one alkyl 2 acyl glycerol 3 glycerol. So this was the last thing we have. Now from this we can actually synthesize plasmalogen or platelet activating factor, and it's very simple from here. If you want to synthesize plasmalogen, you add ethanolamine. If you want to synthesize platelet activating factor, you add choline. So plasmalogen, we are just adding what? In plasmalogen, we're adding what? Ethanolamine as a head group. In choline, in Platelet activating factor, what are we adding? Choline. Now, but you know, for us to attach any head group here, we must attach phosphate group, right? We must attach phosphate group. So what is coming in here is CDP ethanol amine. CDP ethanol amine. So if CDP ethanol amine comes, it is leaving as CMP, because what we are interested in is ethanol amine and one phosphate. So I'll be attaching that here now. So I'll draw that back. I'll be having this. So if I draw that back, I'll be having this. Alright, now check on carbon 3 now. See what I will have now. I will be attaching the phosphate group, because what I'm attaching now is phosphoethanol amine. So the phosphate, then ethanol amine. But ethanol amine, this is ethanol. And amine, I'll attach amine here. So this is ethanol amine. I'll just attach this here from the alcohol. So from here I'll have CH2, CH2, NH2. Alright, what we have on the board here is called 1-alkyl 2-acyl glycerol 3-phosphate ethanolamine. Ethanolamine. This is what we have on the board. The last step in order to get your plasmalogen is an enzyme called desaturases or mixed function oxidase will come in, and desaturases, removal of saturation, meaning, or mixed function oxidase, an enzyme that introduces double bond. So if you check this place very well, a double bond will be introduced here. That's the function of that mixed function oxidase or desaturases. So one hydrogen will be removed here, one hydrogen will be removed here, and add a double bond. The structure you now have is called plasmalogen. So we'll be having CH2O CH. Now double bond is introduced, CH, then arrow. From here, CO. The other parts remain the same, basically. This structure we have on the board here is what we call our plasmalogen. Plasmalogen. So if you are asked to synthesize, alright, please take note. I was omitting my hydrogen here, so please fill it up. Alright, so this structure is our plasmalogen. So basically what I've said so far is, if you want to synthesize plasmalogen, in case it comes in exam, synthesize plasmalogen or synthesize platelet activating factor, just start from dihydroxyacetone phosphate. From dihydroxyacetone phosphate, you add fatty acid. Next, you bring an alcohol to replace that fatty acid. Is it not? Next, you remove that double bond on position 2 and it becomes an alcohol. Next, you add a fatty acid there. And you follow the steps one after the other until you get here. So we've synthesized plasmalogen. Next is we'll synthesize platelet activating factor. Remember I said if you are synthesizing plasmalogen, what is coming in as head group is ethanolamine. If you are synthesizing platelet activating factor, what is coming in as head group is what? Choline. Choline. So basically the step remains the same, but instead of ethanolamine, what is coming in is what? Is choline. Alright, now if you don't want to call this plasmalogen, this is phosphatidyl ethanolamine. Please take note of if they say synthesize phosphatidyl ethanolamine. Phosphatidyl ethanolamine, know that thing is glycerol phospholipid. That's an ester. But if you hear phosphatidyl, anytime you hear phosphatidyl, know it's ether fatty acid. If you hear phosphatidyl, no, it's ester fatty acid. Do you get that? All right. So, if I want to synthesize my platelet activating factor, I said the head group coming in is what? Choline, right? So, CDP choline comes in, and what is giving up is, all right, so you attach your CDP choline, and if you attach choline, everything here remains the same. So the head group here is choline. Now choline, you're attaching 3 methyl group to N. That's the difference you have here. So what you now have here is 1 alkyl, 2 acyl glycerol, 3 phosphate choline. Then the next thing is desaturases comes in to introduce a double bond here. So if a double bond enters here, I'll have this. So I now have a double bond here. Then here I'll have all other parts remains the same. All other things remains the same. So I'll have this. So this stuff we have on the board here is called the platelet activating factor, PAF. Platelet activating factor. So in case you are asked to synthesize plasmalogen or platelet activating factor or ester fatty acids, always start from dihydroxyacetone phosphate and follow the steps. Please take your time on this. Pause the video at every point and draw until you get it.